So we're going to be doing math again today. So if you have your math packets, these ones, I'm going to have you turn to page 8. So we'll kind of be like jumping back and forth between page 8 and 9, but mainly on those two pages. So we're actually going to be talking about quadratic functions today. And so we'll mainly be focused on like solving them. So we're going to do factoring. And then we'll also talk about the quadratic formula.
The whiteboard wasn't doing that earlier.
Oh, I don't know. Maybe it's just me. It always does that with me. Okay. So if you look on page 8, yeah, basically at the top it says the quadratic equation is represented, it has the highest order of a 2, which means that the highest exponent is like squared. So ax squared plus bx plus c is an example of a quadratic equation. And if you were to look at it on a graph, it would be a parabola, which is like that U-shaped graph. Yeah, okay. That's pretty much all from page 8. Okay, so now we're going to start talking about factoring, which is actually on page 9 if you want to flip to the next page. So when we're solving quadratic functions by factoring, we want to get it into like the intercept form, which looks like y equals a x minus b x minus b. And so this form isn't super important to remember, but I just want you to notice that like my p and my x represent the roots, which are also called solutions, or which are also like the solutions to the equation. And then we also call them zeros sometimes. So I think on the ACT they'll mix like all these 3 words up. They'll be like find the roots, or they could say find the solutions, they could say find the zeros. But they all mean the same thing. And so with our intercept form, P and Q represent our root solutions or zeros in our quadratic equations. So if you look at the example on page 9, it started with, at the top, started with x squared minus 7x plus 12. And so they factored it all the way down to x minus 4 times x minus 3. And so our roots were 4 and 3. So I'm going to show you guys how we do that. Okay. So let's say I have this equation. And I'm going to solve it by factoring. So before we even do that, we want to set it equal to 0 kind of. So I'm going to actually subtract this 45 over so that all my x's and terms and everything are on one side, and then on the other side is 0. So now I have x squared minus 4x minus 45 equals 0. So a super easy way to factor is by something called morphing. I don't know if you guys have heard of that before. But basically, you set up a cross. And so it's 4 letters, like 4 sections, M, A, R, F. The M stands for multiply. A is add, R is rewrite, and then F is factor. Okay, so looking at this equation, we're going to start with the multiply step. And then we also, so I put like an M up here, the A down here, and then RF. So that's how I set up my little like morphing cross. So we're starting with M, multiply. So we want something, we want to multiply C, which is negative 45, and A. If we are looking at that, ax squared plus bx plus c, we want to multiply A and C. Technically A is 1, even though there's nothing in front of it, and then C is negative 45, so 1 times negative 45 is negative 45. I'm going to write that up in my little M area. And then we want a number that adds to B. B is negative 4. So I'm going to write that down in my A area. Okay, so to solve this, we're looking for two numbers that multiply to negative 45 and add to negative 4. So those two numbers are going to be negative 9 and 5. If you do negative 9 times 5, that's negative 45. If you add negative 9 and 5, that's negative 4. And so what I'm going to do is write those two numbers in my R and F section. So negative 9 is going to go here, and then 5 will go there. And so with these two sections, it doesn't matter where you write them. You could put the 5 here and the negative 9 there. Okay, so now that I have my little 4 cross thing, I'm going to do the third step, which is rewrite. So what you do is you rewrite A, x squared, and then instead of B, instead of writing negative 4x, we're going to replace it with negative 9x plus 5x. So, and then C, we're also going to leave the same. So it's almost the same exact equation, except instead of B, we replaced it with those two numbers we found that multiplied to negative 45 and added to negative 4. And then again, that equals 0. And so now we're on the fourth step, which is factoring. And so we're going to factor by grouping, which means that out of these 4 terms, we're going to separate them into groups of 2 and then factor those out. So if I'm just looking at x squared minus 9x, what I can factor out of both of them is only an x. Only an x will come out of both. So I'll put my x on the outside. And then still in my parentheses, I've still got an x left and then a negative 9 left. Okay, and then now we're looking at 5x minus 45. So what can I factor out of both of those? I could take a positive 5 out. So I'm going to write plus 5. Make sure that you take either like if you have a positive number, you do a plus. If you have a negative number, you do a negative sign there. And then what's left is x minus 9. So what's inside the parentheses should be the same for both. And if they are different, then you should know you've made a mistake. So you're going to have to like go back and see what you did wrong. Okay, so we're almost done. So when you have x minus 9 2 times, you only need to write it once. So x minus 9 is going to be one of our factored forms. And then the other one is what's on the outside of the parentheses, which was x, and then the plus 5. And then remember to set it equal to 0. And so lastly, to find our solution to this problem, we'll set x minus 9 equal to 0. And then x plus 5 equal to 0. So to solve for x here, I just need to add 9 on both sides, and x would equal 9. Solve for x on this one, I need to subtract 5 on both sides, and then x would equal negative 5. So 9 and negative 5 are my answers to, or are my solutions to this thing we started with, x squared minus 4x equals 45. Okay, any questions with that? Alright, so now we're going to do one where the coefficient in front of A is not a 1. And then I'll give you guys a couple of examples to do on your own. But I'll show you the marking method one more time. Okay, so my next example is, we'll do this one. So 2x squared minus 11x plus 12 equals 0. So again, I'm going to set up my I'm going to set up my x, and then label it M, A, R, F. Okay, so we want two numbers that multiply to, remember it was C and A, so that's 12 times 20, or 12 times 2 is 24. And then we want it to add to B, which is negative 11. Okay, so can anyone think of two numbers that multiply to 24 and add to negative 11?
Negative 8 and negative 3.
Yep, negative 8 and negative 3. So next step is going to be to rewrite that. Remember, I replaced my b with whatever two numbers I found, and then don't forget the x plus 12 equals 0. Okay? Fourth step is to factor by grouping. So I'm going to group those. What can come out of 2x squared minus 8x? I can take out a 2x, so that leaves me with just x minus 4. If I'm going to make sure that my other one comes out, or has an x minus 4, I'm going to want to take out a negative 3. And so that leaves me with x minus 4 equals 0. So inside my two parentheses, I should have x minus 4 and 2x minus 3 equals 0. And then lastly, to get my solutions, I need to set both of those equal to 0. So x minus 4 equals 0. If I add 4 over both sides, I should get x equals 4. And then my second one, 2x minus 3 equals 0. This should be a fraction, so I add 3 over 2x equals 3. And then I divide by 2, so x equals 3 over 2. So my two solutions are x equals 4 and x equals 3x. Okay, did everyone follow along? I feel like I was going a little fast. I don't know. Okay, so now I'm going to give you guys one to do on your own. I don't know if you guys like the morphing method or if you do your own thing, but I'm going to give you a quadratic equation and I'll have you guys solve it and then we'll go over it. Okay, so for this one, there should be 4x squared minus 13x plus 3 is equal to 0. There should be two solutions, and I'll tell you right now that one of them is a fraction. Okay, so I'll start going over it. So we want two, I guess I'll do my turn. Want two numbers that multiply to 12 and add to negative 13. So that would be negative 12 and negative 1. So I'm going to rewrite 4x squared minus 12x minus x plus 3 equals 0. Okay, group those. So I can take a 4x out, choosing with x minus 3. And then I'm going to take a negative 1 out of here, which leaves me with x minus 3. Okay, so we've got x minus 3 and 4x minus 1. So if I set x minus 3 equal to 0, x would equal 3. And then if I set 4x minus 1 equal to 0, x would also equal 1/4. Okay, does anyone have any questions about how we got there?
I finished writing.
Yeah. Okay, so what we're gonna do next, I didn't want to like do a practice math test because it would have like other questions that we're not dealing with right now, but I found some questions. So what I'm gonna do is like write the ACT question up here and then you guys will just solve it. You good?
Mhm.
Okay. So let me erase this. Okay. And to start off with, they are not too bad. Also, I thought I had answer options for this one, but I don't. So you guys are just gonna, it'll be like a free response. And then, oh yeah, what else, the other thing I was gonna mention, on this one, it uses the wording of solutions, but they could also say, what are the zeros for this equation, and it would be asking the same exact thing. So I'll give you guys time to solve that one. I'll read it aloud just in case there's a glare online, but it says, what are the values of x that are solutions to the equation? And so the equation is x squared plus 3x plus 2 is equal to 0. Okay, we'll start going over this one because it shouldn't take too long. But if you'll notice, when we don't have a coefficient in front of our a variable, we don't need to do like the rewriting factoring part of morphing. We can just like jump straight to it. So if you just think in your head, what are two numbers that multiply to 2 and then add to 3? That's just 2 and 1. So I'll just write x is positive 2, positive 1. So x plus 2, x plus 1. Already we're at our 2 factored forms, and so x is equal to negative 2 and negative 1. That makes sense to everybody? Yes? Okay. Okay. We're going to do another like free response one. Same question, except I'll change the equations. Okay, so it's x squared minus 3x minus 28 is equal to 0. And then the question is, what are the values of x that are solutions to the equation? So there should be 2 answers. Okay, so we want two numbers that multiply to negative 28 and then add to negative 3. So that would be 4 and negative 7, is that right? Mm-hmm. Okay, so x plus 4, x minus 7, and so x would equal negative 4 and 7. Those are my 2 answers. Okay. So we're going to do a couple more of these. Yeah, just like 2 more. Let's see. So what if I said solve x squared plus 6x plus 9? Okay, so we'll go over this one. But when we're factoring, we want two numbers that multiply to 9 and add to 6. So that would be 3 and 3. X plus 3, x plus 3. And so when we set it equal to 0, you would get x equals negative 3 twice. So actually there's just one answer, x equals negative 3. You don't have to be like x equals negative 3 and x equals negative 3. And then I did forget to mention, so if they give you like a quadratic equation and they just say like what are the solutions, you can actually graph it in your calculator. So if you guys have your calculator, you want to pull it out. And then since this one is up here, we'll just type it in. You'll have to press that y equals button, which is like the very left hand button. And then I would just type it into y1. So x, and then the x is right next to the alpha button on the left, or on the right of the alpha button, which is kind of like a different color. So x, and then I'll do squared plus 6x plus 9. Once you type that in, you want to hit graph, which is like on the top row is the far right hand button. Just press graph. And then you should see a parabola. It should look something like, this is my xy axis. It's like over here. This is negative 3. Goes like that. And so your answer is actually where the parabola crosses the x-axis. When you just have one answer like this, it means it's only touching it once. Some of our other ones where we had two answers, it would kind of look something like this maybe, where it crosses here and here. So you have to make sure you list both of those, or both where it crosses in your answer option. And then sometimes when it doesn't cross like at an exact number, your calculator can like find that number for you. So what you do is, hold on, let me see. Okay, so I graphed it. Okay, so I'm gonna press the second button, which is like that other different colored button, and then press trace, which is to the left of graph. So remember when the question said like look for the solutions or the zeros or the roots? You should have like a chart where it says like value, 0, minimum, maximum. Because we're looking for the zeros, which are the same as like the solutions, you want to scroll down to number 2 and press enter. And then it should go back to your graph. It should say something like left bound. So what you're going to have to do is move that little cursor thing to the left of wherever it crosses or wherever you want to, or whichever value you want to find. So move it to the left of that, press enter. It should say right bound, and you move it to the right of that. Press enter, and then it says guess. When it says guess, you want to move it to as close to the point as possible, and then press enter. And then down at the bottom, it should tell you your x value is negative 3, basically negative 3, and then the y value is 0. That was kind of like all over the place explanation, but did you guys get that with the calculator? Oh, you have a question?
So if we were on the test, would it be faster just to put in the equation and then get the graph and then look where it crosses the x-axis for answers, or?
So, you know with some of those questions where it had like a fraction answer or something like that, or sometimes it had like a decimal answer where it's not easy to solve this way, then I would do that. But if you have something like x squared plus 6x plus 9, you can easily get 3.
Right.
So I would just, it would take too long to just
Right.
graph it.
Okay.
And then, yeah, so what we're going to move on to next, after we do one more thing, but is when the factoring method doesn't work. So I'll show you guys another way that we can do that. Okay, any questions, guys? Okay, so we're going to do one more example, or one more practice problem. And then we'll move on. And so this one actually has answer choices, so it's basically an ACT question. Okay, so the question is, which of the following is a root of the function f of x equals 2x squared minus 7x minus 4? My answer choice A is x equals 1/2, B is x equals -2, C is x equals -1/2, D is x equals -4, and then E is x equals 1/4. So I'll have you guys solve this. You can graph it in your calculator if you want, or you can do it by hand, and then choose an answer choice option, and then we'll talk about it. Okay, we're gonna start going over it. I told you guys how you would graph it in the calculator, so you can do that if you want, but I'm gonna do it by hand. So, okay. So to rewrite it, 2x squared, we want two numbers that multiply to -4 and add to -7, which is, -8 and 1. Wait, what?
And when you take the 2 times -4.
Oh, okay. I was so confused, sorry. Okay, yeah, 2 times -4, so -8 and 1. So -8x plus x. Okay, thank you. So 2x squared minus 8x plus x minus 4 is what it would look like if we were to rewrite it. I'm actually going to set it equal to 0. Then we're going to group it. And so I'd factor out a 2x, which leaves me with x minus 4. I'm just going to factor out a positive 1 here. And then that, again, leaves me with x minus 4. So we have x minus 4 and 2x plus 1 equal to 0. Alright, so for my zeros or solutions, x equals 4 and x equals -1/2. If we look at our answer choice options, each of them doesn't have 2 answers, they only have 1. But if you look at the question, it says which of the following is a root, and it say like both roots. So they can do that on the ACT. So 1/2 isn't 4, it's not -1/2 either, so it's not A. -2 wasn't even 1. -1/2 was actually one of our options, so it's going to be C. But if we look at the rest, D was -4, okay, our X was +4, and then E was 1/4, which wasn't an answer choice option, or wasn't one of our roots either. So the answer for that one is C. Okay. So now we're going to move on from these, but sometimes we'll give you a quadratic equation that can't be factored, and so we use something called the quadratic formula to solve it. So the quadratic formula is kind of like scary looking, but it's x equals -b plus or minus square root of b squared minus 4ac, and all that divided by 2a. So, yeah, so I don't think they'll give this to you on the ACT, if I remember. But anyway, so when my math teacher taught us about the quadratic formula, she also played this song, which is like to the tune of Pop Goes the Weasel.
That's what I just did in my head.
Oh, okay. Yeah, so I'm going to play it for you guys. Hopefully you guys online can hear it. I'll like turn it all the way up. And then there are like other tunes to the song too. It doesn't have to be Pop Goes the Weasel. But that's just the one I sing in my head, and I'm not going to sing it out loud for you guys because I can't sing. But I'll play it on YouTube. So let me turn my volume all the way up. And then, I don't know, I'll just like put it to the camera or around here. Hopefully you guys can hear it.
quadratic formula's negative b plus or minus the square root of b squared minus 4ac all over 2a.
Okay, so that was the song. And that's how I remember the quadratic formula. If you guys want to like look it up later and play it, because I'm not going to play it again. But that helps me remember that it's negative b plus or minus the square root of b squared minus 4ac all over 2a. So we are going to use the quadratic formula to solve a quadratic equation. So we'll start with, or we'll do this one, x squared plus 3x equal to 5. So remember, we want all of our terms on one side and then equals 0 on the other side. So I'm going to subtract 5 over real quick. So now my function is x squared plus 3x minus 5 is equal to 0. Okay, and so before we start this one, I'm actually going to label like what a, b, and c are. So again, that's going off of that f of x is equal to ax squared plus bx plus c. That's where I'm getting my a, b, and c from. So a would be just like that first term. Again, there's nothing in front of the x squared, so it's technically a 1. My b is like that middle term, the coefficient 3. And then my c is the last one, which is negative 5. So a is 1, b is 3, and c is negative 5. Okay, now that we know all that, we're just going to plug it into our quadratic formula equation. And I'm just going to erase this so I have more room. So I'm going to write x equals, okay, so first is negative b. Well, b was 3, so that's going to be negative 3 plus or minus square root b squared. Okay, so b was 3, so I'm going to put 3 in parentheses and then square that, minus 4 times a, which is 1, times c, which was negative 5. Okay, and then we're not done yet because you have to divide it by 2 times a. And then a was 1, so I'm just going to leave it like 2. 2 times 1 is 2. Okay, so now that we're at this point, what we're going to do next is just like simplify. So I'm going to start with what's under my square root. I'll leave the negative 3 plus or minus on the other side. Okay, so under my square root is 3 squared, which is 9. And then minus 4 times 1 times negative 5. So the 1 doesn't really do anything in multiplication, so it would be 4 times negative 5 is negative 20, but then it's a negative negative, so it actually becomes 9 plus 20. So under my square root is 29, and then over 2. Sorry, what did you say? Oh, okay. Yeah, so this would be my answer. Negative 3 plus or minus the square root of 29 over 2. That is the solution to my x squared plus 3x equals 5. And so they probably have like this as an answer choice on the ACT. And then once you plug it into the quadratic formula, just circle it and then move on. Yeah, so now we're going to do like another example. Do you guys have any questions about this one? No? Okay. So we're going to do another example. I'll leave the quadratic formula up there. But let's say I want to solve, all right, over here, x squared minus 6x plus 4 equals 0. So I'm just going to plug it into my quadratic formula. So x would equal negative b, which b is already negative 6, so negative negative 6 is just positive 6. Plus or minus the square root of b squared. I'm actually just going to write 36 already. And then minus 4 times a times c is also 4. And then all over 2a, which again, a was 1, so we don't need to multiply anything there. Okay, so last step is going to be to simplify. So 6 plus or minus, if we do 4 times 4 is 16. So 36 minus 16 is 20. And then over 2. So this could be your answer, but you might not see it as an option on the ACT. And that's because we can still kind of simplify a bit. So breaking away, let's say I have the square root of 20. even though it's not a perfect square, there is a perfect square that goes into it. I could like break it apart into square root of 4 and square root of 5. So square root of 20 actually simplifies down into 2 square root of 5. Did that make sense how we got there? Okay, so if I replace square root of 20 with 2 square root of 5 in my equation, 6 plus or minus 2 square root of 5 over 2. Well, you'll notice that we can actually take a 2 out of everything. Oh, so that would leave me with, this would become a 3, plus or minus stays. That 2 goes away, square root of 5. And then the 2 on the bottom also goes away. So even though 6 plus or minus, this is my answer. Even though 6 plus or minus square root of 20 over 2 is correct, they might not have that as an option on the ACT because they want you to like simplify it or something like that. So don't be fooled if you like don't see your answer. Don't think like, oh, maybe I did it wrong. Maybe you still just need to simplify a little bit. Okay. So we're gonna move on. We're gonna move on from the quadratic formula just a little bit because I already told you guys. You just plug things in. We're gonna talk about something called the discriminant. Okay, and this is on, I think, page 8 of your math packet. We are going to be talking about the quadratic formula is there too, but we're going to be talking about the discriminant of the equation. So remember I said the quadratic formula like looks like a parabola, or the quadratic equation looks like a parabola. And so we can have like 3 types of parabolas. We can have one where it like crosses the x-axis twice, so it look like that. We could have one where it just like touches once, like that, or we could have one where it doesn't cross the x-axis anywhere at all, so it would be like over like that. And so the discriminant of the equation helps us like figure out the roots, like how many times it's going to cross, is it real or imaginary. So basically to find the discriminant we use that little section of the quadratic formula that was under the square root. B squared minus 4ac. So it can help us determine the type and number of solutions to an equation. So it says there in your math packet, but if the value of the discriminant is greater than 0, that means you have 2 real roots for your equation. If it's less than 0, that means you have 2 imaginary roots. And then if it is equal to 0, that means there's just 1 real solution. So this is an example where we have 2 real roots, where it crosses twice. This one, we just have 1, and this one is the 2 imaginary. Okay, so I'm actually gonna throw some examples up here. I'll leave that up here. Okay, so let's say that I have this equation, x squared minus 6x plus 10 is equal to 0. And then we're going to find the discriminant and describe the number and type of solutions to the equation. So to find the discriminant, I use my b squared minus 4ac little portion. So let me label my a, b, and c. A is 1, because that's what's in front of the x squared. B in the middle is negative 6. And c is 10. Okay, now we're ready to just like plug those straight in. So b squared is negative 6 squared minus 4 times a was 1, and then c is 10. Okay, so negative 6 squared is 36, minus 4 times 10 is 40. 36 minus 40 is equal to negative 4. So my value of the discriminant is negative 4. It's a negative number. So what that tells us is that because my b squared minus 4ac is less than 0, that tells me that we have 2 imaginary solutions. And if I were to graph x squared minus 6x plus 10 in my calculator, you'd see that it'd look like that far right graph where it doesn't cross the x-axis at all. So that's what it means when we have like two imaginary solutions. Okay, so I'm gonna give you guys an equation and I will have you solve for the discriminant and then tell me what it means in regards to the graph. And so these problems, like they go, so if you see this problem on the ACT, you should be like, yes, because it goes pretty quick. You just need to do this b squared minus 4ac business and then decide, does it have two real roots, one real root, or two imaginary roots? And I've seen questions like this on my math ACT test. So yeah, so those ones go pretty quick. But let's say I have x squared minus 6x plus 9 is equal to 0. I want you guys to find the discriminant and then tell me what it would mean. Okay, so b squared minus 4ac, so my b is negative 6. Negative 6 squared is 36. And then minus 4 times 1 times 9. So 4 times 9 is 36. Alright, so we've got 36 minus 36, that's equal to 0. So what does that mean about my graph? Yep, just one real root. And then, yeah, okay, we won't do the last one. Okay, so now, check the time. Okay, now we're gonna do a quadratic formula equation, except it's gonna be a little different than the ones we already did. Okay, so negative x plus 4x equals 13, and then I'm actually going to move the 13 over the other side, but we're going to use the quadratic formula to solve this one. So x equals negative b, so my b is 4, so negative 4, plus or minus the square root b squared. So again, 4 is b, or b is 4, minus 4 times a is negative 1 in this case. And then my b is actually negative 13. And then all over 2 times negative 1. Okay. So now I'm just going to simplify a little bit. So can't do anything with the negative 4 yet. Plus or minus the square root. Okay, so 4 squared is 4 squared is 16. And then we've got negative 4 times negative 1 is positive 4. Times negative 13 is 52. So now under my square root, I have 16 minus 52. So if I were to subtract those, I would get just under, and this is over negative 2. So now I'm going to simplify a little bit more. I'm going to move over here. So x equals negative 4 plus or minus. Okay, so 16 minus 52 under my square root is actually negative 36. And then over negative 2. So you guys probably know this, but we can't have a negative under the square root. So even though 36 is a perfect square, we can't have negatives under our square root. So to solve that, I'm going to use like my imaginary numbers, which are represented by I. So how I write it is negative 4 plus or minus. Instead of like, if we pretend, or if we take out the negative, what would happen is there'd be like an I on the outside of the square root because it's like imaginary. And then we'd have square root of 36. 36 is a perfect square, so I'm actually just going to write 6. And then, oh, sorry.
You do 6i.
Yeah, 6i, not I6. So 6i. So you guys see how we went from square root of negative 36 to 6i? Okay. And then, again, it was all over negative 2. And so that is, like, my answer. But they've all got a 2 in them, so I'm actually going to simplify it a little bit more. And I'm going to take out, I'm going to take out a negative 2. So that would give me 2 plus or minus 3i.
Might be negative 3i.
Oh, because it's already the plus or minus there, we just leave it as 3i. And so this would be like an equation with an imaginary solution. So if we think back to our graphs, if we graph it, it wouldn't cross the x-axis. But this is a way to solve one of those with the quadratic formula. Okay. So we have like 5-ish minutes left. So what we're gonna do, okay, so I'm gonna like throw up a couple of problems up here, maybe like 2 or so, and I'm not gonna tell you which way to solve it, but the ways we've talked about, I'll let you guys just solve it like any way you decide. Looks like they're getting there. We'll just do one. We'll just do one. One example. So I'm not going to tell you which way to solve it, but I want you to decide which way is the best way, because on the ACT they won't be like, use the quadratic formula to solve this one. They're just going to tell you to solve it. So let's say I have negative 3 equals 4x squared plus 9x. So I want you to solve this quadratic equation using like the method that you think is most efficient in this example. Okay, so I started working on this one on the board. But I moved 3 over to the other side, and I think the most efficient way to solve this would be the quadratic formula. So I just did negative b plus or minus 9 squared minus 4 times a times c. A is 4, and then c is 3. All over 2 times 4. So if I simplify it, I should get negative 9 plus or minus square root 33 over 8. You guys get that?
Yeah.
Okay, so that was the last one for today. If you're online, you can head off. Unless you have any questions for me, you can stick around and ask them. But thanks for coming, guys.